Welcome to the Flat Earth site that explains everything, explains the whole model. Today is the second lesson for Simon Dan and his followers, a science lesson that explains how the Flat Earth works. The last lesson was showing him how the southern sky moves around the northern sky. There's our Flat Earth, northern rotation. Out here we have a southern hemisphere rotation, and it turns all the way around the northern rotation over 24 hours. What is turning the whole system is the centre Earth vortex that we do not see. That rotation is seen turning the stars at night above the north, because there's a Polaris. As it's turning, it's reflected out here at night and seen turning in the southern sky. But because it's from a different perspective, it's a different set of stars to what we see up here. Now, we showed this in the last video, turning like this. We have to realise this is everywhere, because it's a projection of a circle, a circular motion in here. Its stars are everywhere out here, projected out here. But you will see your southern rotation wherever you stand and look south, because you're in line with north and south. That's your rotation. If you're standing here, you'll see your rotation there. All the way around. You'll see the same stars as everyone else, except they'll be in a slightly different rotation. What's happening here is they're being brought together, because this is what happens. They swing into the tropics, pass down through the earth. It's the magnetic field. Swings out of the south, passes down to the earth at the tropics. High pressure being pulled down by low pressure. Low pressure is rising, high pressure is being pulled down. This is how the system's working. They're being pulled together. I'm going to show you how that works, Dan. Simon Dan. We have a southern field and we have a northern field. Like that, Dan. And look how they're converging as they turn. They turn together and those lines are all converging. All at the tropics. See how that works, Dan? Like that. That's how it works. It's the convergence point at the tropics. That's what this gap is in the night sky we see. Up there above the equator, Dan. If you don't believe me, go to this site. Look at that. Toroidal field. Solar, magnetic. All there in the solar winds. What's this? What's this? The intertropical convergence zone. Convergence zone. Or ITCZ. In the region that circles the Earth. Circles the Earth. Near the equator, where the trade winds of the north and the southern hemispheres come together. The intense sun and warm water of the equator heats the air in the ITCZ, raising its humidity and making it buoyant. That's what happens, Simon Dan. See, the high pressure comes down and raises up the low pressure. That's the push and the pull, drawing the field down to the earth. The magnetic field is the high pressure. Positive equals high pressure, north and south. Low pressure, negative. The tropics. That's why they're being pulled together, because they're being drawn down into the tropics. You understand that, Simon? Drawn down to the tropics, where they pass down through the earth and come back up to repeat their cycle, just like that. Simple. Eh? Moving west in the night sky. Why don't we see all the planets and everything in the northern sky, Dan. They're in this strip out here. The strip, because that centre point, this is centre point here. Polaris, Sigma Octantis. The sun, the planets are all there. That's the southern view. You don't see this looking down through a vortex. How can you see it all down there amongst all those other stars? It's obvious out here. And the planets are right there in the strip. Right there in the middle. Reflected out here, where we see them, in that strip. The ecliptic. There's the elliptic angles inside here. All the stars are all moving on this elliptic. It changes like this over the season. That's aphelion. That's perihelion. Not what science tells you. That's equilibrium. That's the equinox. Everything's dead level then. That's when the moon travels in furthest to the north because the sun is coming level. You haven't got that long elongated elliptic. It comes up here, so the sun doesn't have to wander out as far as it normally does. It comes in a lot further. That's where we get our very high tides and low tides at the equinox for 3 days. It's right there, equilibrium. Don't know that, do you, Simon Dan? You got that, Simon? See? It's turning. It's all coming out from the centre. All projected out into our realm. Turns. That turns. It's creating this to turn. You have something turning up here in a bowl, glass bowl, reflection, lights. We see this turning. You get the opposite rotation on this convex curve. It's the same rotation, just seen, showing stars on a different angle, a different perspective. So that turns, and everybody gets to see their own rotation, but the star will be in a different location. Cannot be in the same place from 3 different continents. Okay, got that, Dan? These are the magnetic field lines. They curve like that because this field is pulling it. It's all being pulled, turned this way. It's being pulled in, and then it passes down to the tropics. Down and back under the earth, back out here. To come over again, go down through the tropics, come out here. The southern magnetic field is the same as the northern magnetic field. Did you know that, Dan? Dip compass told us that more than 100 years ago. They both dip here and there, but they don't dip at the tropics because that's the opposite. That's the opposite to these. That's the magnetic attraction, if you want to talk about magnetic attractions. Opposing force. High pressure, low pressure, Dan. You have to understand this, Dan. What's solar winds? The sun. We live in an electromagnetic world. The sun is electromagnetic. It sits in the electromagnetic field of Earth, in our horizon. We spoke about that last time, didn't we? The arc of horizon, the sun shown, formed as like a cone made up of all the light spectrum, condensed to a white disk that you see directed at you as an individual. That is it. Like that. Condensed down to a white disk directed at you. That's how it works. It's a bit complicated for the spinning ballers, but it's quite easy if you open your mind up and dump the spinning ball. It all makes sense. That's all I have to say for Simon Dan.